Hi, welcome to this organic chemistry quick video. This one is over organometallics. Now, this could really be a full semester, so trying to squeeze it all into 5 minutes is going to be a little snuggly. We're going to talk about a lot of different types of organometallic chemistry. Essentially what you have going on is you have an electropositive atom attached to a carbon. Usually it's sneaking on in between a carbon and a halogen. Oftentimes you'll see bromine in there. And because you're becoming attached to something that's extremely electropositive, it's going to donate its electrons back to the carbon, and carbon will be negative. So the more electropositive that you have of a metal, the more reactive it's going to be because it's going to make that carbon more negative. And as you know, carbon doesn't like to be negative, so it will react. The first one is going to be a Grignard reagent, and that's what we're showing here on the left-hand side with magnesium. This is a very general reaction, and you can do this with magnesium or lithium. It will work exactly the same with both of those metals. Depending upon the reagent, will give you the different type of product. For example, if you have a ketone, you're going to end up with a tertiary alcohol by adding on an additional carbon that's coming from your alkyl halide that's shown above, and then your double bonded oxygen will kick off to become an OH. And on down, you can read the rest of them. Ester is the only one that's a little bit weird in there. It actually will give you two different products because you have two different side chains with your R groups. Over on the right-hand side, we have lithium and copper, and this one also does have a name, but I'm not going to make you guys know the names. This is showing you the different types of reagents and the different types of products. The pink R is coming from a alkyl halide, just like you saw with the Grignard reagent. However, it's its own separate step after you make your lithium and your copper part of it. And you can make a little bit more variety with copper and lithium than you could with magnesium and lithium. If you have a double bond and you add a zinc copper mixture with, that's methyl diiodide, or with a nice big bulky base and some trichloromethane, you'll end up forming a cyclopropane. This looks a lot like the epoxides, and it's kind of a similar type of a reaction. However, instead of adding an oxygen across the double bond, you're adding a carbon. It is important to note that there is specific stereochemistry depending on if you have a cis or a trans going on. These three reactions are using tin on the first one. The second one is palladium with either zinc, aluminum, or zirconium. And then the one on the far right is going to be using boron with palladium. It looks probably a little bit crazy on here, but the very first one, the X is just showing you which halogens you can use, because you can use either chlorine, bromine, iodine, or OTF. OTF is just another excellent leaving group. And then this is showing you your R groups that you can use from most to least reactive. And then similarly on the middle one, you have different metals that you're kind of substituting in. So where it says the green Me, that could be zinc, aluminum, or zirconium. The pink R groups are shown, and then also the blue R groups are shown. And again, you're just forming a carbon-carbon bond with almost all of these different reactions. On the right-hand side, you're showing with boron. The green R groups aren't really necessarily, it's not that they're not important, but those aren't going to be a part of your final products. That's just showing you some of the typical R groups that you can see. And then the blue and the pink R groups are what are going to form your carbon-carbon bond. And then finally on here, we've got the top one is showing you with palladium and an alkene. You're essentially replacing the most available hydrogen with a carbon. Okay, so it is going to replace the most accessible one. Then down below, we're showing olefins, where you can use molybdenum or ruthenium on some kind of a catalyst, which the catalyst can be a lot of different things, and that will switch up the R groups that you have across a double bond. That's all I've got for you guys on this video. I hope it helps. Thanks.